We can.
Okay. So, good evening. Hello, everyone. Welcome on the DataOps meeting. My name is Tomasz Gintoft, and I have pleasure to be hosted today. I mean, the maintain of this meeting. So, just a quick reminder about the idea. It's DataOps meetup, so we care about the data. So it's dedicated for data engineers, data scientists, DevOps, and it's all these roles participating in the pipelines. So welcome. And today we have our guest, Simon and Michał, but we already announced the next hour meetup. So it's June 23rd. And it will be the way from the POC to an automated model factory. And our presenter will be Radek, and he's the lead of the data scientist. So yeah, you can already reserve your time. And also, if you are from Warsaw, don't forget to join to our group, because the idea is the DataOps Poland is dedicated for the whole people in Poland, and will be online streaming. But times to times we would like to meet you in Warsaw, and we believe that coronavirus will go away in near future. So we'll meet in the Warsaw, drink a beer and eat good pizza. And that's all from me. Welcome our guest, and stage is yours, Simon and Michał.
Thank you. You can share.
Yes, let me switch to the presentation. Okay. Probably should be able to see it now.
Yeah, we see it.
Day-to-day work and managing life infrastructure. It's revised title for the presentation. Originally, we are exposing it more from the data visualization side, and streaming in like rather simple way.
Yeah, mostly that the first idea about our talk was that actually everything that streams can be easily represented in and seen in an infrastructure that actually allow you to see all data that flow through your platform in human format way. That actually is not just a byte array or something like this. Sometimes for clients or from architects are something hard to understand. So this is why we decided to have this talk called at the beginning data streaming visualization in Lecce. Lecce because actually is the product that we use for that.
So we we're both working at Grid Dynamics for over a year. It's, as a part of the same team, we've been using Lecce from the beginning. As you earlier asked, how did we step upon like DataOps as an idea? To some degree, it was literally shoved our way, but we managed to find we found it very interesting, and actually we spent quite a lot of time evolving this solution, and right now we've got the whole platform running on top of Lecce with fully managed with configurations. So start our talk, and its contents will be split into two parts. After the first part, we'll have like a short Q&A. It will be more of a technical side, and the second part will start with the introduction of the demo domain, and we'll show the live environment, what can you do with it, and what can you especially see in it. So what is lenses and what is its purpose? Enterprise DataOps for Kafka. That's actually something that can be found on landing page of Lenses.io. And it can be used for multiple different things, especially data management and visualization, but also to some degree, you can manage your infrastructure with it and integrate with actual streaming applications on many levels.
Yeah, I think is especially that regarding built-in integrations is something that we use a lot in our day-by-day activities, and it's really nice because you have everything already built in, so you don't have to integrate some libraries or some other frameworks or some other infrastructures. It's already there. You just need to adopt your application to work with lenses, but actually it's something really easy that in 2-3 lines of code you can already have. So it's something really quick, and it doesn't require a lot of work behind.
Oh, maybe not 2-3 lines, but maybe
yeah.
20, 30. Yeah, but probably you could squash it to that much.
With indentation, yeah.
So how the lenses looks like and how do you use it on daily basis? The first dashboard and actual landing page from the lenses application shows you that in those informations about active services. You can see the state of your infrastructure, amount of nodes, amount of data, and topics, running connectors, consumers, processors. What are those? We'll talk about more later. You can have, you can see the schemas in Schema Registry. That's the basic overview, but you can actually go into details.
Yeah, let's say that actually the landing page and the service details is the first information that actually you want to take a look when you just arrive to work and say, okay, let's check how is our production environment. So if during the night something happens and or you want to monitor the status, the workload at the beginning, you just right after login, those informations are already provided there. So it's something that sometimes is really really useful and needed for especially infrastructure maintenance team or for DevOps. If they, for example, have to run another deployment because some servers goes down, and usually you have to go on shell script, check the stuff, and in this case you have everything already there with the simple green button that at least say if the server is up or not. And also there is the number of nodes that you have. That is important point when you have distributed systems.
And you can see like specific data for each node. So maybe one of the nodes is overloaded. You can check it why. You probably already have some alerting for that. There are also tools to integrate with alerting systems over Prometheus. But that's something you can browse quickly. But that's definitely not the main point of this tech talk. And from my perspective, the actually most interesting part of lenses is live data information about topics. You can browse all the topics, either internal system topics from Schema Registry or lenses itself. You can even get to the data from topics like consumer offsets, which are literally Kafka internal information, directly here when you access the system topics. Here we got examples of from our demo. You can see the amount of records in each of the topics, You can see the types of the topics, amount of consumers, partitions, replication. And there's also like filtering with dynamic filtering by string with pattern. So when you go into the topic detail, when you open the topic informations, you got additional detail. You can directly check the consumers with their groups, informations about partitions and how the data is spread across them, access topic metrics, configurations, schema. But here, like the main screen here is actually the live preview of the data, and you can run actual SQL queries on top of the topic, filtering with proper filtering, grouping, and multiple different operations. We can even open it with live sampling, seeing the incoming records in real time, and maybe change the representation of data from like human readable to even raw format of like JSON AVRO representation. We can even download it directly from here.
Yeah, as Michał already said, that this tab, I think, in our opinion, is the most important, because usually when you want to check the kind of data you received, the format you have, you usually have to make a client, or during the tutorials about Kafka, they said you have to create a Kafka consumer, and then you can see what kind of records you have. In this case, Lecce provide this SQL format language that actually can provide you structures that are really similar as normal RDBMS language, in order to directly read and see what you have directly in the topic. You can even check, as Michał already said, different data, but another important point is about the download, because depending on the format you choose, you can download data, and this is something that, especially for analytics team, can be really important, because you can provide the results of these topics without creating any client. You can directly provide them this data in offline mode, and they can analyze with some tools for analytics, or even if you are working on cloud, you can export them, make it directly available on some nodes on Google Cloud or on Amazon, and they just go there, take this file and process it. So you can choose two different formats, and one important one is the sampling, as Michał already mentioned, is really important, especially when you have, for example, high throughput streaming platform, and you want to see dynamically how many data you are receiving, the format that you receive, especially if you are in a phase of POC and you don't know actually what is the incoming format and what you actually have to process later. You have everything as a preview here of what you will do later.
Other thing that's really interesting here, there's actually built-in producer directly from this view. You can, clicking on those three dots, you can actually generate some example which using the Schema Registry will actually be auto-generated even. At least according to Schema Registries for restrictions, which are very broad, but that's still something. And we often use it just for testing some simple processors or Kafka applications, just to even see if something is wrong or not, and testing something in real time. I've already mentioned the Schema Registry, that you can browse the schemas. And so there's like one of the really nice features is that you do not only can browse schemas, you can actually create new schemas, and you can even export the schema creation statements as some curl files in JSON format. So it's actually something we actually use in our production setups, where we, using those formats, we actually exported the data and have it as a part of our configuration.
Yeah, for who has never worked with Kafka, Schema Registry is one of the most important features if you want to take care of the data format. So data format, data validity, and I think also is one of the hardest part of regarding maintenance, because sometimes you have data that change regarding, for example, clients' information, or what actually clients say. I think we need another field before say we can do it, we cannot do it, and directly test it here, and then you can make it even with the automation tools. Make it dynamically deployable and dynamically editable. And Ansys provide this really nice tool that actually allow you to modify the schema directly. And in this case, you have the all related part regarding schema, regarding format validity, even just for test. Before make it, before put it on GitHub repo, or make another deployment jobs just for check what is the result of that. You can directly do it from UI. And Lenses directly tell you if it's allowed or not.
Yeah, there's like a real-time schema validation when you try to perform schema evolution operation. As you can see on this screen, like every schema, whether you're trying to create it from scratch or edit some, the first step would be to validate it, and then you can actually perform the change. That's like Lecce also provides like a single API front for operations on our registry that are actually authorized using Lecce's users with proper
grants.
Yeah, with proper grants. So the other part are connectors. The idea here is the same as in case of as in case of the Schema Registry, where you can create connectors directly from within Lecce with real-time validation for mandatory fields. And here we've got example of Cassandra connector, and you can see that it already tells us that there are some fields without default values missing. And we can actually get like optional fields, so we can get a list of full properties supported by a specific connector, and then even once again export it as a part of configuration.
As everybody can see here, that one important target of Lenses is to allow you to have everything as a continuous integration. And what is the best way for reach this target is to have everything deployable or everything modifiable directly from DevOps jobs. And most of tools are, for example, using HTTP REST API, and with Lenses having this curve, you can directly, as Michał already said, get authenticated in the platform itself. So on Lenses platform, and Lenses platform will communicate with all nodes belonging to the same cluster without authenticate to everybody. On every server on any node. You just need to send a curl request on Lenses REST API, and Lenses REST API will take care of everything that is underneath.
Yeah, like one important thing, like Lenses is not something that stands like from my perspective, Lenses is something that's built on top of Kafka. It's not something that can replace it in any way. It definitely, it's rather something that integrates with Kafka and serves as a gateway to manage whole environment. So now we've got now we've got another part of lenses, which is strictly related to streaming. We had multiple occasions where people were, like clients actually, were expecting multiple different things when they heard about Kafka, like SQL on top of Kafka. Some things that are inherent to RDBMS.
Yeah, this is something that actually happened in our projects when we said, oh, actually we have this tool that actually is provided by Lenses, is LSQL, and the client only heard SQL. So they ask, oh, okay, so considering that we have topics with 1 million records, can we make an aggregation for 1,000 days and check what is going on? But why the UI is low, for example, because they are loading, I don't know, 2 million of records. And they said, okay, but maybe we can do indexes on this date in order to have the query that is faster. And we said, no, wait. Or the last one that actually made us really flushed was about multi-joins. They said, okay, but Oracle can. Yes, but Oracle is not streaming. And sometimes it's really hard to explain what actually is the difference. No, but lenses make the difference to understand easier, because one thing is to explain what is a streaming. Another thing is to let them see is the streaming and actually how the processor behind, or even the engine itself behind, perform all that they need in a speed that actually is definitely not comparable with the RDBMS.
So here we've got LSQL query engine. This is something that you can access directly from the topics view, but here it's like there's like separate SQL Studio, which allows you for more streamlined access to the data. And yeah, you can definitely do such things like the joins operations here. Maybe not with multiple joins on top of different conditions with very broad structure, but to perform some simple queries, yes, you can definitely do that here. And once again, you can extract the data. You can provide your analytics team direct access to this, direct access to this SQL Studio for like real-time data, real-time data access with additional restrictions for some confidential information, which can be obfuscated.
Also, this functionality is available also directly from Lenses API. So even without logging in the platform, if you want just to provide the client access to some specific group of people, you can directly do it. And as I said at the beginning, you can integrate Lenses with a lot of common tools used in operations and for development teams. Directly is already built in, it's like a black box, but with the difference that actually you can integrate it with everything. And in this case, you just need to provide the query, and the query will be performed on the client part. And you can get just the results, even without logging into the platform.
And with LSQL, there's another part, which are SQL processors. Those are actually fully operational Kafka Streams applications that perform some operations that are defined with the same SQL structure we've seen previously in SQL Studio. But here they actually produce data to some specific outputs. As you can see, here you have general overview on top about the processors in the system, information about runtime, active tasks for it, and current information about messages received and sent. So how the SQL processor actually look like? It's very simple structure. On top of it, we have a few lines regarding the basic configurations. Those are applied to the destination topic and have some also put some requirements on the producer. So we have informations like configurations like replication factor, commit interval, partitions, meanings in replicas. Here we have only one because the instance we are using comes with a single node of every service.
And actually for development parts or for just play with lenses is more than enough. And yeah, one part about the section on top is that you can lenses provide you some settings and properties that you can set up, but also here you can set all Kafka Streams properties that you usually put in Kafka Streams applications. But in this case, they will be directly injected in the application that will work under our nodes.
As from the application itself, it's configured with 3 lines. Literally, we define the destination topic, we define the operation, and we define the operation to perform on the input data, which here is actually simple filtering of our movies. And one thing that Simon has mentioned previously was that Lenses allows you to easily show the client how the data behaves and how it behaves, especially in streaming. This processor comes with a topology graph. If, and we had such situations, client comes with an idea of very complex operation, we can actually inject it here, show this you're trying to do with your data. Are you sure that's the right approach?
Yeah, and also provide you, once you try to perform the operation in one way, you can see, for example, if you have problems about reshuffling or if you have several aggregations that are not required, topology provide you directly the path that actually data will do. And in this way, you can think about some improvements to apply. Things that actually, if you want to make with the normal Java application or Scala application, depending on the language you want to use, it requires to change the code or even write several codes. In fact, we have a mantra for that every time says, and we will tell you in the next sections about LSQL processors. Because in SQL processors, you have 3 lines that actually are doing a lot of work behind, and also there is a diagnostic of that, so you can check actually what are you going to do.
Yeah, and you forgot to actually say those words. SQL processors, Kafka Streams application, right?
Yeah,
I think it's sometimes you definitely have to write Kafka Streams applications. There are operations that you cannot possibly do with SQL statements, at least not for now. And yeah, in many cases, operations such as filtering especially and simple ETLs can be done directly with such processors. There's also example of topology on top of whole infrastructure. And here's how the basic topology works, where we load the data with source connector to the topic. And here we have a processor that actually filters the data, the processor we've just seen.
Yeah, this one is a nice overview of actually the application. We showed the part that was the technical part of the processor, but then in the whole ecosystem, this is how the processor will look like. It will be marked as an application that is connecting one source topic to a destination topic. This is something that is really important, especially from, for example, the designer's overview of the pipelines, because you can directly see some dependencies from which topic to which topic, where the data came in and where the data can go out, or especially if you have like normal pipelines when you are in production, that you have several topics, several processors. In the topology, you will see actually all processors where are connected. And this is one of the really important features that we use in our daily jobs.
Here's like previously I've mentioned that you can provide your analytics team an access with some restrictions to confidential data, and that's something that's provided with data governance and policies. You can create your some custom policies for data reduction, and here's how it looks like. Here I've prepared some example GDPR policy, and our client's row ends up being reducted to purely to initials. And now every single time when there will be name or name surname, and there can be multiple different wildcards for and templates for name patterns for the policy itself. Everywhere we will have name, surname, we will have this reduction policy applied.
You can also choose to who applies these restrictions. So if you are administrator or you are developer, you can specific grants on that. But if, for example, make it only to the analytic person that actually is who designed the pipeline, but actually don't need to know exactly what is inside the data, but just the structure. And you want to cover like card number if you're in financial security, or in marketing you want to cover the name and so on. So for this kind of this group of people, you can apply these policies. And actually Lenses provide you already, I think, more than 20-30 policies for that. I mean, different combination of policies.
No, those, you mean like reduction policies? Mm-hmm. Yeah. Here you can see like a cutoff list, like all email, first few digits, last few digits, characters, sorry, initials. There's quite a lot of them here. You can also see how many topics get affected by specific policy. So that's also a really nice thing to have. And there's also administration panel, which contains quite a lot of configuration. We won't go into specifics for everything, but from the things you can see here are like audit logs for operations performed on the infrastructure itself. And the current state of infrastructure with alerting rules, with also ability to create custom rules for alerting, and everything from the alerting side can be integrated with some standard alerting systems externally. So
Lenses already provide out of the box all JMX exposed. All settings that actually are already are needed for the most common tools. I would say that actually this part is not part of our daily work because it's more related to infrastructure part, and usually DevOps team take care more about this page. But I would say that our DevOps team that actually work with us use a lot, because you can see everything, especially audit log, because sometimes it's really important to know who, for example, changed the schema manually because used, for example, admin login and they said, oh, let's try to play with the schema. Maybe you are in dev or in test environment. Or you can see some processors when they, especially if you have some tools that restart the processor if it goes down for any reasons, you can see when it happened and when it has been restored. So you can think about how many data you can have delayed, especially if you're working in marketing and environments or in financial environments. It's really important to know from when to when these data were unavailable, and especially if you're using external tools for expensive aggregations. So yeah, audit logs also allow to have filters regarding on which node, which category, who performed the operation. In our case, is from what we can see is admin, but in the normal environment can be admin, can be analytics, can be developers. You have several groups, and you can even filter about it.
So I guess for now we can have a brief Q&A.
Yep. May I?
I cannot see the questions nor chat.
Yeah, because do you hear me?
Yes, I can.
Yeah, cool. So if you, any of our attenders, would like to ask you a question, please, there is the option raise a hand or let us on the chat, because currently all of you are unmuted, so let us know. So I have a few questions, if I may.
Go ahead.
Yeah, cool. So because I'm the Kafka Apache Kafka administrator, I would say. So it's I have a few questions about the product. If I would like to show, read the messages between offset 3 and let's say 5. Is it possible? To show it?
Sorry, to see
messages between offsets. As far as I
yes,
know, yes,
part of metadata.
You can actually access metadata filtering. We can show that later during demo part. Because from the SQL perspective, you can statements perspective, you can actually access metadata. So you can even perform operations like on timestamp filtering, which is even better than offsets.
Yeah, you can filter for example, you can combine in LSQL Studio. You can combine, for example, filtering based by topic partition or partition offset. For example, if you want to do it only with, for example, topic and partition, you can directly do it with another tab that is not with SQL, so you don't need to write some SQL command. You can directly do it from the UI. You have the 2 buttons, and you can choose directly which partition you want to see. The same for offsets. And yeah, but as Michał said, sometimes it's better to perform it directly on timestamps if it's not something that actually you can do it only with offsets. But yes, you can easily do it.
Okay, and the next question, because sorry if it's lame question. The platform itself, it's you can install inside in your infrastructure, or it's in the cloud, on how it looks?
All of them are directly provided by Lenses. We usually we are using it Dockerized, for example. But yeah, for example, on some other projects, we have the Docker image about the Lenses platform, and we configure the settings in order to be
Do you have any other questions?
Yeah, I have at least few. Yeah, so about the HA, I mean high availability. So is it only one node, so it's single point of the failure, or it's more complicated? How it looks? Because you said it's only the Docker.
You're talking about Lenses UI.
Yeah.
About Lenses UI, yeah, we always use, I think, with the normal single node, because
yes.
But Lenses UI actually is just, you know, something on top of your environment. Then everything else is independent. So you can have several nodes of cluster of brokers, zookeepers. Just Lenses will give you just the endpoint for visualization or maintenance. So it's on you actually if you want to have two nodes and use a load balancer for that.
Okay. And is there any option to manage the Kafka cluster? I mean, example, if you would like to add the new node, so it's like just clicking, or you need to do it manually and it just appears in UI?
For what I know from our DevOps team is related to Lenses is something related to configuration. So once you created your new node, you can just make the node visible from Lenses platform.
Okay.
I think it's using like zookeepers, like for brokers, like auto discovery mechanisms. So when you another node in your broker cluster, will probably even get automatically discovered. Actually, I never tried it. As Simon mentioned, we rarely manage infrastructure itself.
Yeah, my question was more about that if you can manage the Kafka nodes, or you can manage only the topics and data inside. I mean, by the nodes, I mean you can create one, remove from the cluster, make the maintenance, or you just manage the data, not the solve the Kafka ecosystem.
No, you cannot manage a Kafka ecosystem directly from Lenses.
Yeah, okay.
Data, it's purely for data management. When it comes to infrastructure, it's still part of like some configurations with probably Helm charts for that.
Yeah, imagine Lenses as an external tool to interface with Kafka, not a Kafka manager. So you can do some stuff that actually can be done with, would say, REST API, with APIs in general, instead of go to command line, to play with command lines. But yeah, regarding infrastructure part, no, it's something that is always related to the cluster itself.
Yeah, so you can use Lenses to monitor the state of the cluster, get this, like represent the information about it, but not manage it directly.
I think there is a raised
Yeah,
hand.
there's raised hand, yes.
Wait, let me check.
I click on
Conrad, maybe now?
Okay, can you hear me?
Yep.
Okay, so guys, I have a question regarding LSQL. How is that similar, and how is that corresponding to Confluent's KSQL? Is KSQL somewhere underneath, or is that completely different tool? Could you elaborate on that?
LSQL is directly provided by Lenses and is present, I think, from version 1 before Confluent provided is language for, not for streaming, but just for visualization. So Lenses provided before the Confluent. About SQL processors in the older versions was converted, was just a kind of parser of KSQL. But in the latest versions, Lenses improved their own engine, and so it is completely something different than Confluent one.
Actually, I'm not sure how is the current state with Lenses. LSQL versus KSQL, because I know they're improving it very, like they are constantly improving their system, and as far as I know, they're planning to roll out quite a lot of improvements by the end of this year that cannot be possibly done in KSQL. Like, as far as I know, the biggest improvement that is upcoming is UDFs on top of SQL. So
on top of SQL processors.
On top of SQL processors, because currently you can write UDF functions, but they can be only applied in SQL Studio mode with for analytics, not for data processing.
And as far as I know, Confluent only in the last version provide this kind of UDF evaluation, but is still this, as we say, a rare status. Is not fully ready. So I would say that actually is a continuous race to who make the first innovation about that, and then it depends, of course, on the cases you need. I would say that UDF, for example, because Michał mentioned, is something that, especially for who works with integrations with legacy systems, will be really important, because everything that you usually need to create to develop with the custom Kafka Streams application can be easily converted in an UDF. And of course, it's better to have just a function that will be lazily called instead of have a full operational Java application that is running in background waiting for messages. And also Confluent, I say that is not fully ready about that.
Okay.
Konrad, do you need anything? I mean, any questions? Okay, I have a question about the connectors. I mean, Kafka connectors, because I saw on the list there is at least several of them. So they are managed by Lenses, or it's like community, or?
It depends. Some of them were prepared as open source connectors by Lenses, and quite a few of them are present out of the box. There are, I think there are like 50 connectors out of the box, something like that.
I don't remember the number, but yeah, there are, especially in version 3 of Lenses, a lot of them are included. And yeah, they are directly provided by Lenses. So if you also check on GitHub, they have the source published about some connectors that are part of the project that is called Stream Reactor. And yeah, one thing that especially me like a lot is that everything is developed in Scala and not in all the Java versions. So they also are going to stay updated also about JVM technologies about that.
Okay, thank you for your answers regarding KSQL versus LSQL. I may have another question about also similarities to Confluent stack around connectors. How are those Lenses platform connectors similar to Kafka Connect? Maybe do they have their own solutions for managing those connections to various databases, or they use something from Confluent stack underneath?
Yeah, underneath there is still Confluent. You you don't have to buy the licensed version. For example, sometimes we use the community version, and yeah, once you deploy the connector, it works on top of Confluent platform.
Okay.
The same actually goes for LSQL processors, because there are a few modes that they can be deployed in. Like by default in Lenses box, they were deployed like in memory processor of the Lenses itself. I think that with newer Lenses box versions, they're deployed on top of the Connect cluster, and they're interfaced as a connector from the process management perspective. And there's also the possibility to deploy them as Kubernetes pods.
Okay, my suggestion is let's switch to the live demo, okay? And
actually, if we can have like 2 or 3 minutes break.
Yeah, sure.
To set up everything, yeah.
So we'll be back in, I guess, let's make it like 5 minutes to 7 p.m.
Cool.
Right.
That's okay. So it's up to you guys. Maybe let's start some discussion, and someone would like to have any questions or something like that.
Okay.
Filip, Grzegorz, jedz, Michał drugi, Sebastian. I will pause the record. Yeah, no.
So how we mentioned on the first part, here is the our UI, the landing page of Lenses. That right now the environment is purely empty. So I created a new Docker image that we will use, and here we can see that all services are health. Topics, of course, live data is 0 because we have nodes. The rate that we can see here is just related to system topics for monitoring and for infrastructure informations. Here we have SQL Studio, administration tab, policies. So everything is here. In our demo, we will perform deployment and maintenance based on Lenses API. So we can share, for example, how to generate a connector, single connector. We log in Lenses platform in order to have a token that actually is the same token generated when you log in from the UI. And then Lenses provide you all endpoints related to the feature that you want to use. So we mostly use shell scripts for deploy, undeploy, generate a new environment, move the environment, for example, if you want to make it on another clusters, or if you want, for example, to reuse the same product, you can even make a set of shell scripts operation. And in this way, you can directly interface with Lenses.
I would say that in real environment, you'd rather use like things like Terraform and Ansible for managing this, all those things, and that's how our DevOps team has actually set it up. But yeah, for the purpose of this demo, we used simple shell scripts.
Okay, so as we can see here, we prepared everything in a folder. So let's come back to first. Here we created a generator that will feed our data source. So I think you can share the screen for the first parts.
Mm-hmm. So
You can choose.
Yes, yes.
Because here we have a representation of our demo. So
yeah, our demo is called MovieFlix Analytics. We're doing, we've simulated some infrastructure for retrieving analytics data from the streaming platform. And here's our here's the topology we're aiming to achieve. We've got some database input from for clients information and movies information, which are very static data. And we've got a producer which creates, which is constantly running and creates a stream of views performed by all the clients.
yeah, what we are going to reach actually in this demo is to make with lenses something that can happen in some really important products that are famous for movies, for music players, that where, for example, you have clients informations and movies, in this case, informations that are something already present, are not streaming, are tables with domain tables. And then you have the producer that actually is something that continuously generates new data, new messages. That can be, for example, a player, a web player or an application player. And in this case, it's dynamic, so we make it as a Kafka producer.
It's, here we've got some informations that are performed with Kafka streams. Maybe not, it wasn't important and it wasn't needed, but we made it just to show how the integration with lenses itself can be performed. But the main part here is like Spark streaming application that actually performs join from three topics with windowing on top of the views table. Topic.
So yeah, let's say that this our demo is an example of analytics application on lenses. Yeah, the main target is to provide on the destination data source the result of the biggest aggregation that actually we performed with Spark, but all operations that needed to be fast and easy to write actually were really easy operations, like filtering, like projecting, or maybe even a simple join. We decided to have it in SQL processors because are faster than Spark. Because Spark, we don't have to forget that is based on micro batches, and Kafka streams, like also SQL processors, are continuous reading. So in terms of performance, from end to end are faster than Spark.
Here's the basic schema of our input information. We've got input from source connectors for clients and movies, and we've got stream of views, which is directly mapped with the other two topics. We've mentioned Kafka Connect integration. Here are the connectors we have. Two of them are source connectors. You can see the type of for each of them. One is the sync connector to store the processing results in some external storage. And how here we can see the connectors configuration, which can actually be done, which can also be done directly from lenses, as mentioned previously. But here you can see, like preview the configuration itself, how the connector was set up, and you can also notice that things like connection password are obfuscated. There is a flag in connectors themselves that they can mark some of the some of the properties as vulnerable
All
data.
sensible data, so you can provide like lists and in connector or in processor or in administration panel, everything will be obfuscated. I think our password is also directly in the last versions are without any flags already. When C password is already covered.
Yes, but that's part of the connector itself.
Mm-hmm. Yeah.
And yes, here you can also edit the connector or stop it, pause the tasks, restart. Here also you can see the amount of data that was processed by the connector itself. We also have extended LSQL processing. Simon has mentioned previously that clients really love their multi-joins, and we had an example where we received like 200 lines of stored procedures worth SQL code, and we're told we want this in LSQL.
They said put one was at the beginning of one of our projects, and the target to reach was to make as a stream something that previously was done as a batch. So the client arrived and said, we have this stored procedure, then the data right now are processed on daily rate, and now we want to make it in stream, so real life. Like I say, oh, okay, that sounds challenging, sounds really important. Let's check what are the processing and aggregations they need. We open the files and we start to scroll, and this stored procedure never ends. And say, okay, but we cannot do this in streaming because at the end, the performance and the number of aggregations we have to do will make the streaming processing smaller than what is designed to. And this is after I don't know many complainings about why we cannot. We had to perform a meetup only for them in order to explain how streaming actually works, and what actually, looking at the name, some important business logic, because for the client this one was an important logic, but also the next one was an important logic, also the other one was an important logic. And when you end with inner join, or sorry, with several joins in a streaming, it means that is not a streaming anymore. So this is why we decided to put this slide in our presentation, because if you decide to move on this kind of environments and you before work with batches, it's something that you will face for sure, especially with clients that have really old legacy systems.
Yes. So what you actually can do with LSQL, you can perform join operations that use, especially for joining table to stream, where we actually use clients as a enrichment K-table, and stream views joining the information from the client's topic. So here you can see the topology underneath, where we've got a table from the topics. We select some of the fields, and it's also then it's once again represented as a table. But from the views perspective, we've got repartition because we are changing the ID of the. We're not joining on keys. So with case streams, we have always performed join on keys. So LSQL performs this repartition for you out of the box. In perfect scenario, we could actually configure our source connector to mark the client ID column as a key. And then we could, that's one of the things that Simon has mentioned, that seeing this graph, you can find the places where you can improve on with your design.
Especially, for example, when we talk about high performance streaming, if you see that, for example, the join operation is not the last operation, but is the first, it means that something is wrong, because one thing is make joins with 1 million of records, one thing is to make it with 100 records. So, yeah, we have repartition here. We have a temporary topic that will be used for join, but at the end, the join will be done on, first of all, organized data. So because we have repartition on one side and also repartition on the other side, because the gray topic is a topic repartitioned, because you are projecting different columns. So the join will be performed in the fastest way as possible. So on this page, you can see actually how the streaming will be at the end.
And there's also another example of client activity where we simply perform aggregation by client ID, and we can see the amount of movies that any client has viewed.
Yeah, this one also is a pure example of stateful operations compared with stateless, because here the aggregation on the group by will be done on the topic, on the K table itself, compared with the other one that we saw before that was a mix between K tables and K streams. If in lenses you can do also group by in LSQL, sorry, in LSQL you can also do group by on streams, so on stateless operations. But in this case, lenses ask you to provide a windowing interval in order to make the sliding window for the aggregations.
Here we specifically dropped the previously we used select stream for the main input topic, and here we're using purely select, which enforces the operation to be treated as K table. Which because of that we can actually perform group by operation without windowing. So finally, coming to the integration with external systems, what we are using is integration with this is the single class that I've mentioned that maybe will take like 20 lines of code to write to integrate with lenses. And like, to be honest, it's not very, like, it is even similar to something we use in production for the integration.
Yeah, except print line or yeah.
Like here is the like purely bare bone integration itself, but it really does not differ from something you can use directly in production to integrate. And on the right side, you can see Docker image we are using. Our Kafka cluster is actually something that Lenses provides out of the box, called Lenses box. You can retrieve license for it, like request license for it for free, and it comes with the structure we've shown you previously with single Kafka node, Connect clusters, Zookeeper, and Lenses UI itself. And here we're just linking it to our Postgres example database. So let's stop sharing.
Yep.
And now.
Okay, so let's come back on our environment. Here we have our streaming of views that already are started. And actually, as I said, is just for us a Kafka producer. So we just trigger the generator of views. And what we will do is to deploy all connectors that we need. This command, I will show what we'll do. As I said before as an answer, in this case, we have Confluent community in our Docker. And what we are going to do is simply to put our JDBC connectors on Confluent node. So here we see the JDBC that actually is the one provided directly with Confluent. A set of transformations that we are doing. Of course, being part of these clusters, you can do some custom transformers, custom converters, even custom connectors if you need it for some specific purpose. And if you add it in the class path, automatically will be visible also on Lenses. So Lenses will be integrated directly with your connector. And if, for example, you want to create a new connector directly from UI, your custom connector will be present here. And you can actually use everything that actually the connector gives to you, and also use the settings about custom properties. So what we have now in our ecosystems, after connectors deployment, we have our source connectors that actually got messages from our databases. And next step will be to deploy all processors. I will show, first of all, the code. Processor. So really, maybe it's better too. As I said before, you called for getting a token. Then the request will be call the endpoint API streams, passing the JSON that is from the request we have in inbound. So no, I can't put this. Okay. So calling the SH, we have the deployment. Of course, in the production environment, there are several tools used for continuous integration, but in our case was just enough, even just copy paste. But in this way, we have always already there, and we can just trigger it with SH. And we can go here. So our processor are going to be deployed, and we can see already from connectors we already deployed how many messages have been received and how many sent. I think there should be a third one. Okay. So let's check now our status. We can see that actually a number of topics increased because in our processors, we set as a result of our application to auto-generate the destination topic. And in this case, you also delegate the processor to generate automatically the schema. So if we take a look at Schema Registry, we can see that all schemas are created automatically by our SQL processors. For example, let's check another one. This one, as Michał showed before, is a simple streaming streaming application that filters. In 3 lines, you have done an application that, if you want to emulate in Kafka streams, will be open the stream, stream.filter, and then provide the Lambda function, and then 2. You need more time to build your framework and also to deploy your application than just insert these 3 lines plus settings. This is why we always say that a SQL processor is an application that you don't have to write. Also, here we can see that actually our topology is going to be the one we show at the beginning, that is our final destination. Here we have our producer with also metrics provided by Lenses. So talking about the integration with Lenses, we can see that in our topology client is just a dependency for Maven or SPT, depending on how you want to build your project. But at the end is just a method, register and unregister. So with two simple commands, you can build your topology. You can also expose metrics, and those metrics will be directly managed by Lecce's platform, even if the application is a custom one.
There's one thing that you have to remember about the topology, that topology is purely declarative, and underneath it works as actual messages produced into Lecce's system topic. So you can actually mock your topology and prepare it without any actual structure present in the system. So you can prepare the meter, you can, something we even done here in this demo, when we were preparing this demo, is that we made the topology first without the applications underneath. We just had empty jars that were declaring some topologies and registering themselves. And we could have the full overview of how our data will be processed directly here.
Yeah, and especially in design phase of one project, you can you just need to analyze all relationships between different topics or between different applications. In this case, before delegate your development team to start to work on it, you can say, oh, sorry, can you please provide me the topology of following these rules? So this topic, this processor, this connector, this custom application. And then you can even go to your client, or if you're a product company, you can build your first version of solution and say, okay, this is what we will reach at the end. Is it something that we can optimize? Is it something that can be added now during designing part instead of making during development? Because once you start the development, everybody knows that for streaming, it's not that easy to modify dependencies without affecting the performance. So it's something that you can check before start the operational part. So what we have now, we have our producer that in the meantime is still continue to create views. So we arrive at the phase with the processors. And next step will be to run one Kafka Stream application. This one is a custom Kafka Stream application where the purpose is just to read a file that can be somewhere, and for all incoming messages, we got to do some operations based on this file that actually contains, in this case, mapping between nations and continents, so country and continents. In order, because our analytics team, in this case, wants some data about the most visualized movie, newest movie per continent. So what we will do in the end will be just to wrap and group all informations divided by continent based on the client. This is why the target of this Kafka Stream application was to read this dictionary of all countries with the related continent.
In real life operations, in real life applications, it would be probably some kind of access to external, probably to some external service to enrich your data. But yeah, here we are using, here we are emulating it with some external hard-coded values.
Yeah. And here, from what we can see, there is topology. Case, the topology was quite complex because we have to provide all information about, this one is more a framework. So this class will be used by all our applications, but in the normal environment, maybe you need just to provide the topology for a specific application. So you don't have to try to reach the most generic approach for that. In our case, we directly prefer to discuss this more generic one because maybe we will need in our projects in the future. So in this case, we can just bring this part of code, move it to our application and reuse it. That actually is what we have done for this demo. Okay, so we deployed our application and we can see that a new component of our topology has been added. And this component is actually Kafka streams, markless application. Of course, you can provide every name for your application because in the topology, you have to define as a first step the application ID. And here we have clients, that is our input topic. And here is clients continents, that is our destination topic. Good feature about topology is that thanks to this, we can see that actually clients are consumed by this processor, but also by this application. So in this way, you can make your data flow more clear and understand what will be the final step.
It's also really important in cases where you can expect some data, like modification of the data structure itself. You can seeing this, you can see the impact it can have on your platform.
Through, yeah.
Because let's say someone in client activity says that they want some additional value at the end of the bottom pipeline. But wait, we need for this, we probably need to retrieve more information from clients. We will affect some different pipelines and require changes in multiple different steps.
Yeah, for example, if the source connector in this case, change the value. In this way, you can know easily which topics will be affected if they will use the new value. I think we can go to the next step. Our next step will be
run views producer again.
I know. Okay, as I said, our Spark streaming will perform windowing on views. So this is why I run again the producer, and you can see that topology got updated immediately right after deployment of the application. The first thing that will be updated is topology. Topology for us is just a REST API, but actually in under the hood is simply a Kafka producer that writes to this topic. And here we can see that our topology our application producer have this kind of topology. So the app type, Kafka producer, name, and all dependencies. So which topic is parent of the kind of application, and so on, so on. So everything is converted as a Kafka topic.
Yeah, I believe that previously Tomek asked about browsing topics with partitions, so we can go to that. So let's see our movie content counts for content.
Yeah, this one is no, this one maybe I can check one that is bigger. For example, this one. I think I have to stop something because, of course, everything in local is quite painful. Yeah, as Michał said, here we have all informations about metadata. And if we go in SQL Studio page, we can do like select star from was view. So limit 100 because I want to see if metadata. So should be where metadata, no? For that. Score
dash metadata.
Offset greater than.
You can actually use between.
Yes. Okay. I don't remember. 100 and 150. Oh, it's between was not like this.
I don't know. Okay, maybe just use greater than. I don't remember the proper signs for it.
And then done. And we can see offsets that are 101, 105.
And you can actually here you can actually see which partition the data comes from.
Yeah.
It's directly in the topic view. You can
Meta partition, for example.
no, I mean that directly as under the row representation, you can see the offset partition and timestamp
Yeah.
in human readable format. And direct accessing the Kafka topics view, you can browse the partitions themselves.
For example, here you can choose partition, and you can even do from the UI, starting from 100. Let's do 1000. And records limit 200. And here we have offset 1000. So in this case, you have not the range that actually was asked, but you can do from when.
And then limit the records number. So
at the end, you have actually a range.
You can also show how the data generator works. Like insert, as I previously mentioned, you can insert messages here
and
like using auto-generate, but you can also extract the data itself in a raw format, which previously we filtered. And you can directly copy paste key value, maybe modifying something, or just using the same message
you can directly
you had originally and try to reprocess it. Maybe if you had some message that resulted with, let's say, error during processing step. So after tests, you can try to use it for reprocessing, and the data has been already inserted. Now you can try searching by the key, by the ID.
By the key.
Yeah, it's ID.
So let's start from view where underscore key equals of course here we have something like millions of records.
No, it's I think it's for key. Use access by value.
Sorry?
Filter by value. If it's ID. No, just,
no, wait, ID.
Just ID class. ID view. ID view. Yeah, it takes some time.
Yeah, of course, depending on the amount of data, because
I would say that even more than amount of data is that you've got Spark job and streaming and Kafka producer running on local machine with Docker app. It really takes a toll.
Oh, the way I can. I chose. Oh, I just needed to stop. Okay. So here, yeah, we have directly everything provided, and we can directly download, as Michał mentioned, and everything will be exported as a JSON, and we can reuse easily this file for every specific reason. Okay, another point we want to share is, let's imagine about an I grade. So we have Kafka Stream, we have Spark, We have everything running. And now let's still use this one. The feature live sampling. Here we have our inbound data, and all data generates are being fetched directly by our application, and you can see in real time. You can pause, you can resume.
Actually, what's funny about this, that all those operations are actually creating consumers for Kafka, and you can even see them in consumers page, that they are some kind of dynamically created consumers with LSQL as a part of their group, consumer group. So, yeah, I think that from the demo part,
yeah, one thing. So okay, we have our Spark job that in the meantime completed. So just for finish the path of our data, we can connect to our Postgres, and here we have from views movies count, and here we have for each time window the amount of total visualization for movie and for continent. In this case, the time window was something like 5 seconds or 10 seconds, and was not a lot. But of course, it depends on the kind of analytic you want to perform. But we can see that actually there are records and records and records directly provided by the sync connector. That is one we provided by from reading from the topic feed by Spark streaming. So I think we have reached our target in terms of topology, and also finished. You want to add something?
Yeah, I wanted to add that simultaneously I was running the same demo on my own laptop, but Spark just failed without a memory exception. Too many things read at once, really. It's fairly enough.
Okay, so any questions? I can see one from chat. Maybe between 100 and 150 would work as for standard SQL. What do you mean? Okay. It was about the sometimes we have we work with one monitor with code and the other one with Google Chrome or Safari only about lenses functions, because sometimes you try to do it with functions you have you already know, but in the newest versions maybe lenses release other set of functions. And of course, when you have to remember all of them, especially changing between processors and SQL Studio, it happened that actually you don't remember, because yeah, SQL processors use different syntaxes sometimes compared with SQL Studio.
Yeah, it's very rare. Actually, as far as I know, the keyword between that we try to use is actually something new. What? Keyword between that we actually try to use is actually something that has been released in recent version.
Okay, last question from my side, because I saw that Schema Registry support only AVRO. Does it support also the protobuf?
Protobuf? I don't think so. It doesn't support only AVRO. As far as I know, it also supports JSON.
Yeah, JSON AVRO, yes, it's the most common.
Technically, this is like standard Schema Registry. You can like this is not the solution from Lenses. They just integrated with it greatly, and actually you can write SQL processors using JSON, but as far as I know,
that's Elasticsearch.
Oh yeah, there was Elasticsearch integration added recently too, but as far as I know, like the AVRO is like dedicated, like the format they are focused on, and that's where you get the best performance.
So, last few seconds.
Technically, if the protobuf is supported by Schema Registry, which is not part of Lecce itself, they probably do support it to some degree. Maybe not on the level of operating the data and changing the schemas, but at least browsing, I believe it should be working correctly.
Okay, so last few seconds for questions. Michał and Simon, thank you for the great presentation. Definitely, I will download the lenses and check. I mean, run some tests and try to how it works in my environment in the Kafka. And yeah, I think that's all tonight.
Yeah.
So take care, and once again, thanks for the great presentation. I can bet you spend a lot of time, and thanks for your effort and time.
It was a pleasure.
Yeah.
Okay, and I hope we will meet someday on the Kafka or somewhere about the DataOps.
Sure.
Actually, like here you can see the Lenses IO download stage for this developer's license. Like, as far as I know, the responder for license is automated, so you get license in a matter of few minutes.
No, even less. Last versions are really immediately because they send just the EULA.
Okay. Yeah.
So thank you. Bye. Have a good evening.
Thank you. You too.
I hope
Bye-bye.
you like this. Have a nice evening.
Bye.
You can find us on LinkedIn if you have some questions, of course. So feel free to contact us if you want some information or some deeper details about it.
Yeah.
Have a nice evening. Bye-bye.
See ya.
Bye.